Today we're going to be sharing with you all the physiology of anaphylaxis. Maybe you've had an allergic reaction or you witnessed somebody else have an allergic reaction. My brother was eating in the lunchroom as someone else who was eating peanuts and his throat was swelling up. He was going into anaphylaxis, but luckily he had his EpiPen on him. He was okay as well. It's wild how something as simple as peanuts can affect people in such dramatically different ways. Today we're going to be talking about why this happened, and the physiology behind this, and what families should know to be able to protect their loved ones and how to spot the differences between severe and mild reactions. The images to the left display mild symptoms such as sneezing or hives, and then attached to the left is a video of someone experiencing anaphylaxis, and as you can see, she's having trouble breathing. What is anaphylaxis? Anaphylaxis is a very fast-acting allergic reaction that happens after coming in contact with something you might be allergic to, like a certain food, animal, medication. And anaphylaxis will have effects, or it could have effects on the skin in forms of hives, swelling, and the respiratory is also going to be affected. That's why, you have the difficulty breathing or even throat swelling. And anaphylaxis can cause an extreme decrease in blood pressure that could affect other organs.
Three types of mechanisms of an allergy would be immunoglobulin E, mast cells, and basophilus. Immunoglobulin E are allergy-detecting antibodies that triggers the immune response, and it binds to mast cells and basophils. Mast cells and basophils are both white blood cells that circulate in the blood vessels or bloodstream within your skin or lungs. With mast cells, they are the line of defense against harmful substances, and they fight infections, and they help regulate blood flow and promote tissue repair, whereas with basophils, they release histamine and other chemicals to increase blood flow, and they signal other immune cells to respond to infection. There are 5 different types of effector cells of anaphylaxis. You have mast cells, basophils, macrophages, neutrophils, and platelets. With mast cells, they are a major player in allergic reactions. They bind to the immunoglobulin E on the receptors, and these cells matter because they lead to physical symptoms such as airway constriction and swelling. Basophils also respond to immunoglobulin E-dependent activation, and they release mediators like histamine, and it matters because it helps recruit other immune cells and increase inflammation. Macrophages, they trigger these mast cells and basophils, and they play a role in repairing tissue. They digest and engulf allergens. And macrophages, well, this matters because it enhances studies of treatment. Neutrophils, they also release histamine during anaphylaxis, and they release granules to boost tissue remodeling. And this will help understand the role in expanding therapeutic strategies. And lastly, platelets, they also contribute to anaphylaxis. They release mediators, and doing so, this can help lead to treatments and therapeutic interventions.
So when a person is exposed to an allergen again, it's going to bind with those IgE antibodies that's already built up the first time on the mast cells and the basophils, and they're going to release these chemical mediators. And those main mediators that are going to be released are going to be histamines, PAF, and the cysteinoleucotrienes. And those leukotrienes, those are lipid-based, and they're going to have very similar effects, but they all kind of do it a little bit differently. So most of the things that you're going to see here is going to be vasodilation, you're going to see swelling, inflammation, you're going to see bronchoconstriction. So think difficulty breathing, things like that, which is really important. And another thing to think of is the more of these mediators that are released, the greater the response is going to be. So if all these are released and the cysteinoleucotrienes are all released in full force, you're going to have a huge response rather than a smaller allergic reaction.
So we've talked about the key mediators involved in anaphylaxis. Now let's look at how they actually affect the body. So histamine is one of the most powerful drivers of symptoms. So it impacts everything from the respiratory system to cardiovascular, digestive, and skin systems all at once. It does this by binding to 2 key receptors, the H1 and H2 receptors, and each of those has distinct effects. So those H1 receptors cause things like the airway constriction and rapid heartbeat. That's why breathing becomes difficult and the heart starts to race. Those H2 receptors contribute to things like flushing and headaches as those blood vessels dilate. But beyond histamine, cysteinoleucotrienes play a major role in the lower respiratory system, as well as the cardiovascular system and the skin. So these mediators lead to things like coughing, wheezing, tachycardia, which is that rapid heartbeat, increased vascular permeability, leading to swelling. So you might also see some redness, flushing, itchy skin as those blood vessels expand. And then finally, those PAFs are specifically going to affect the cardiovascular system and the skin. So they'll further contribute to swelling, hives, and potential circulatory collapse.
Treatment and emergency response mechanisms that are used to treat anaphylaxis include epinephrine, also known as EpiPen. Epinephrine is a form of adrenaline that is given as an antagonist at the first sign of any of the previously mentioned symptoms. Epinephrine interacts with receptors in the body through stimulation of the ALK receptor to reduce swelling in the airway and narrowing of blood vessels in order to increase the heart rate and blood pressure as a counteraction to the sudden drop in blood pressure caused by anaphylaxis. Beta-2 receptors activate in order to open and relax the airway of the lungs and blood flow to the muscles. It also inhibits mediators released to restrict the immune system's overreactive response to an allergen.